So we have two special trig ratios that give us some special limits. And so we have the limit as x goes to 0 of the sine x over x. Now, if we plug in 0 here, we're going to get 0 on bottom. And the sine of 0, remember your unit circle? The sine of 0 is 0. So this gives us 0 over 0. Well, that's an indeterminate form there. We can't use that. So we're going to need to figure out another way to find this. And we won't go through the details right now, but it comes out to be 1. We'll show you the picture real quickly of why. Because here we have, this is our angle, theta. And this is the sine of theta. And as the angle gets really small, these two pieces become almost identical. So the sine of theta is almost identical to theta. Since they're almost identical, this goes to 1. Okay? Our next ratio, or limit, is the cosine of x minus 1 over x. And if we plug in 0 here, we're going to get 0. And if we plug in 0 there, this becomes 1. Plug in 0 for x, and this whole thing is going to be 1. And so 1 minus 1 is 0. So this whole thing becomes 0 over 0. So 0 over 0, we don't know what that is. So we need another way to think about that. Well, here's how we can think about that. If I blow up this angle here, this picture I should say, and we look at this, we can see that this distance right here, which is, it comes out to be, this is 1 minus cosine of x. Let's convince ourselves of that real quickly. This distance, this is the unit circle. This distance is 1, and this is the cosine of x. Or, we should be consistent here, cosine of theta. Okay? So that 1 minus the cosine of theta is that little piece, and as the angle gets smaller, that little piece is going to disappear. Okay? And this here is theta. So you've got a long arc and a little piece. So when we have 1 minus cosine of theta over theta, this is going to go to a worthless piece over something. So this is going to go to 0. All right? Because that top part is a little tiny piece that's going to disappear. Okay, so we're going to use those limits. So as we are working with these limits, we're looking for these fractions. We're going to try to make things look like one of those because we know those now. We're going to memorize them. So here we go. Here, we got a 5x, but what we're going to do is we're going to say let 5x be u. So we can rewrite this as sine of u over u. We're just doing a little substitution there. Okay? And, well, when x goes to 0, what's happening to u? Well, as x goes to 0, u is going to go to 0 because u is 5 times x. So 5 times 0 is 0. So u is going to 0. So we've just changed this to u going to 0. All right. Now, well, that looks a whole lot like the one we just talked about. We know that the sine of theta over theta, or the sine of x over x, or the sine of u over u is going to go to 1. And there's our answer, 1. Okay. So you don't actually need to do this u replacement. Anytime we see that this is the same as this part, then we can just say that that limit is 1. You don't have to do the u substitution. Well, what about this one? We're looking for a sine x over x. Well, we can rewrite this. So we're going to split this into two fractions by dividing both of these terms by x. So we have x divided by x plus sine of x divided by x. So this limit of these two things is the same as the limit as x goes to 0 of x over x plus the limit as x goes to 0 of sine x over x. So we can split that up, and we're just using some properties of limits where we know that the sign, or the limit, should say, of f, if this is f of x, plus the limit of g of x is equal to the limit of f of x plus g of x. That's what's going on there. So, well, this is just going to, x over x is 1. And we know that this is our memorized limit that we just found, and so that's 1 also. And so we get 2. All right, well, we got a tangent. Wait, we talked about sine and cosine, but we didn't talk about tangent. Well, we know some identities that we can use here. We know that tangent is sine over cosine. And so here, now we've got a compound fraction. So you can convert this in a couple ways. If we multiply by the common denominator, which is just cosine of x, then these guys cancel. We're just multiplying top and bottom by that because we don't want the compound fraction, which is just a fraction in a fraction. And we get this. Well, as we saw in that picture up above, that we talked about sine x over x. Well, they're both going to the same thing. They're both going to 1. So it doesn't matter if you flip them around, because when the x is 0 and the angle goes to 0, they are the same. Secant. Well, we didn't have any secant. We had 2 limits, one with sine, one with cosine. So this one, we can do this a couple ways. Let's see if we can change it into cosine. Might be one way. So remember, secant is 1 over cosine. All right, because we know something about cosine. And we got a compound fraction here. So let's multiply the top and the bottom by the common denominator. What's the common denominator? Well, it happens to be cosine for top and bottom, right? Okay. So here we got to distribute that thing. So we get a limit as theta goes to 0. And we'll distribute this guy. Cosine theta times 1 over cosine theta is 1 minus 1 times cosine theta. And this on the bottom is theta. These are going to cancel. Now, our limit that when you look in the book, and in most books, you'll see it as cosine minus 1. It's going to 0. Well, this is equivalent to saying the limit as x goes to 0 of 1 minus cosine x over x is 0. So, same thing. You might have noticed in my quick explanation there, I actually changed it around to 1 minus cosine x. A little easier to see there physically, because this distance is 1, this distance is cosine, so this is 1 minus cosine. But the point being, this little bit is going to 0 over theta. That little bit is disappearing. So it doesn't matter which way it is. If you want to factor out a -1, you could do that to make it look exactly the same. But we know that's going to 0.